Hi, this is Dr. Schick, and welcome to another episode or demos in coding. Today we're going to be coding the inheritance exercise. What I'm going to show you right now is what I call the inheritance exercise, or also the shapes demo. Oh, you want my cam? Alrighty, there it is. So in this demo, we're going to be using files that you can find in the old code examples inheritance exercise. Notice that there are 1, 2, 3, 4, 5, 6 different files. The one file that's very interesting is the object driver. This is where main is, and this will use the other files. One of the other files is called ishape.java, and this is an interface. How many of you have read about interfaces? So Carlos has, Herbert has. So an interface is just a base class, and it forces derived classes to make a method. So base class says anyone who can, in this case, anyone who is an I shape will be able to do an area and be able to do a circumference. And area and circumference will return a, I believe it's floating point answer. So in order for you to use the I shape, in order for you to be an I shape, for a class to be an I shape, it must be able to do those methods. And that's an example called method overloading. And then we have 1, 2, 3. Class A, we have circle and rectangle classes. Circle and the rectangle classes are shapes, and so we'll see how they use the iShape interface. And then we have something that's called the shape factory. Now, factories are a design pattern, and if you get good at object-oriented programming, you'll want to learn design patterns. Design patterns are old ways to organize your code that will help keep your maintenance costs low. So if you have remembered the waterfall method of the software design pathway, the largest and most onerous step in the waterfall method is maintenance. You've already created your programs and you're maintaining them. If you use the design patterns, your maintenance will be minimized. So that's the overview. Let's dive in and see what we have here. We'll start by diving and looking at the object driver itself. So the object driver I have over here on the left side, and we look at main. All main does is run something called test inheritance. And this is how I frequently organize my test drivers. I make some function called test inheritance, and this allows me to build my object slowly, testing each object at a step. So I have a test object copied before, and I'm no longer running test object copy, I'm instead running test inheritance. So main really is test inheritance. So let's look at test inheritance. In test inheritance, the very first thing I do is I make an array of I shapes. So an I shape is just a shape, and an I shape must be able to do area and circumference. So we look in lines 39 and 40, we see that shapes do area and shapes do circumference, and this I shape is some kind of base class. Then I make a list of things. Here I make 10, so I have a for loop, I do it 10 times, and into this array of I shapes, I'm calling my factory and calling the make method. Now the make method creates a random shape. If you look at the files that I gave you, there's a rectangle and a circle. And in this example here, I also have a triangle. So I've made three real shapes. We can see the 3 real shapes I've made over here. I have a rectangle, I have a triangle, and I have a circle. If you know your geometry, you know that the area of a rectangle is height times width. We know the area of a triangle is half base times height. Let's see, where is it? Area. It's a half base times height, so it's different. The function is different from that of a rectangle. And we know the area of a circle is pi times the radius squared. So these 3 different shapes have vastly different ways to calculate their area, but they are all I shapes, and they all have the same function called area. So the function name is the same, the function call is the same, but the method or how the function works is different for these 3 shapes. All those 3 shapes implement the I shape interface, which means they can do what an I shape is. So let's look and see what an I shape is. Up here I have what an I shape is. It's just a class known as an interface. So it's a specialty class that has what are called 2 abstract methods. An abstract method is a method. You know what methods are, but notice there are no curly braces here and no code. There's just a semicolon. Say, I know how to do area, but really I don't. I know how to do circumference, but really I don't. Someone later is going to do this for me. And that's what an abstract class is. It's a class that defines what subclasses are going to do. So we go back to our main. We're making 10 of these random shapes. We're making 10. I don't know if it's a rectangle, I don't know if it's a triangle, I don't know if it's a circle, because I'm using a random number in this shape factory to do that. Then I run a method off the list. I call this method called print shape. I'm printing the shape, and then I'm going to do a comma space. I'm going to print my shapes with a comma space behind them, and then a new line. So I have a list of shapes coming out when I run it. So let's run it and see what it does. There's nothing. Oh, here we go. The first time I run it, I make 10 things. I have a circle, triangle, circle, circle, triangle, and so on. Notice that they all print areas and circumferences, and that they tell what they are in different ways. A circle just has a radius. A triangle has a base and a height. And a rectangle, where's my rectangles? Have a height and a width. So they all slightly different shapes, but they all know how to make an area. They all know how to make a circumference. So all main does is make some random shapes and then print their areas and circumferences and what they are. Let's look at the print function. Down here is print shape on line 37. It just prints the shape by throwing it at print. And then it prints the area with a format. And it prints the circumference with a format. Now earlier I'd used formats on strings, and the system out can also print using the format signatures. So we see %2.2f. It's going to give me 2 decimal places, or 2 digits after the decimal place. It's a floating point format, and it'll give me space for 2 areas in front. And so that should print the area in the format 45.38, or digit, digit, point, digit, digit. It's not 0 padded. That's all that main does. Let's look at the shape factory next. Adjacent to my 3 shapes and the interface for all shapes, I have an interface or a factory for all shapes. Now, a factory knows what kind of shapes there are. And to record which shape is which, I have what's effectively an enum in C++, but in Java it's a list of final static values. So the circle is going to be index 0, rectangle is 1, triangle is 2, and the number of shapes is 3, so I know how many different shapes there are. Then we have this make function. Let's look at the make function. I'm going to move the main over. This make function, main is calling the make to get a random shape. And this is going to return an eye shape. Notice returning an eye shape. But instead of making an eye shape, it's going to make a new circle, or a new rectangle, or a new triangle. And it does this by calling the make function that takes a flag, what shape do I want? So this factory can make a random shape using make with nothing, or it can make one of the shapes that it knows how to do by passing the right flag to the shape. We can see an example of this use of the make function in the bottom of my main. Here I'm using the shape factory, calling make and asking it to make me a circle. I then set the radius of the circle, and I print the radius. So we're going to get back to the fancy casting business in front here shortly, when we talk about superclasses and subclasses. So if we look at this make function, the final make that the factory does, once it knows what kind of shape to make, it calls the constructor for that kind of shape, but it returns it as if it's an eye shape. If you remember yesterday, we talked about superclasses and subclasses. A subclass is a superclass. So a circle implements a shape. That means a circle is a shape. A rectangle is a shape, and a triangle is a shape. So we can use a shape variable name to point to one of these derived classes. We do not have to have a circle pointer. We don't have to make a circle in order to have circles. All we need are eye shapes to have circles in them. And that's what's called polymorphism. This is an example of polymorphism. So let me point out polymorphism and tell you why it's so important, or why it is so powerful. Here, I have an array of eye shapes. And all an eye shape is something that knows how to make an area and make a circumference. That's all we need to know about what eye shapes are. When I use eye shapes down here in print shape, I'm using the eye shapes. In print shape, I take one of those shapes out of my array of shapes, and I pass it to print shape. And print shape only knows it's a shape. And all shapes can do are print area or circumference, and so that's all I do here. I also call the toString method. iShapes don't know how to do toString methods, but their corresponding shapes do. Their derived shapes do. So here we have the derived shape, which overloads the object's toString method, and we see it prints the radius, it calls it a circle, and it shows the radius in the label. So I have an array of shapes. I don't know what kind of shapes they are. In fact, when I call the make, I get a random shape. I have no idea what shape it is. Then I print those random shapes, calling my print shape, and the print shape calls the area and circumference, but it doesn't know what kind of shape it is. When it goes to print the toString, instead of going to a generic toString, it finds the toString in the derived shape. So somehow the information from the derived class is there. So what's the last thing I want to show? We can change things. So as you start up, I can make the triangle class disappear completely. And to do that, all I need to do is hide my triangle class, change my num shapes to however many shapes I have. Now I only have 2 shapes. Remove the triangle class from my case statement. And without changing main, I've removed the triangle class from main. So let's rerun this again. And we see no triangles show up. So here's the power. I can add or remove new shapes to my already existing program by simply creating a new shape that derives from the iShape class and adding that new shape to the factory. The iShape function, my program, does not change at all. And I've added something brand new. When you are maintaining your programs, you'll often want to add something that's brand new. If that brand new thing implements some kind of a derived class or base class, then that derived class, that new thing, will run in your program without you having to edit the program at all. And that is a very powerful tool that you can use to decrease the amount of time you spend maintaining your code. So in summary, to create polymorphism through inheritance, you need a superclass. Here I used iShape. You need derived classes of that iShape. In your function, you're going to make an array or use variables of that superclass, not of the derived classes. And of that superclass, it uses what is called overriding methods. When I call the make here off of an iShape, the program will first go to iShape and see if it has this area function. It does not. It knows how to do it, but it knows that it could do it, but it doesn't know how. If it doesn't know how, it then binds to the derived shape. So in the circle, I have a area function that does know how to work. So instead of trying to print the area of the iShape, I go to the circle and use the area's circle function. That one does know how to work, and I print the area of the circle. And that is called function overriding. Instead of using the iShape function, it uses a circle function. Now the last point I want to make is that I have these iShape objects in my main. An iShape object has no idea that it is a derived shape. So I cannot use getRadius, I cannot use setRadius, or any of the circle-specific methods from an iShape variable. So S cannot do s.getRadius. We can try it, and it will not let us do it. S dot, all S knows how to do, see if we can find it, hello, is area, circumference, get class, and all the things from the object. It does not know how to do get radius, get circumference, set or get radius. So all that iShape knows how to do is what an iShape can do, but it runs the derived classes methods instead of the iShape methods. And that is it for polymorphism through inheritance. For those people who are running the Schick pathway, I'm going to ask you to download, when you're doing the inheritance exercise, you're going to download the code that you find in the old examples inheritance exercise. You're going to add a triangle to the code and make it work. To add the triangle to the code, all you'll need to do is create a triangle class and change the shape factory. Do not touch the object driver code. When you turn things in, when you're doing inheritance and you want to submit it to me, make sure you submit all the files. You're going to submit the driver file, you're going to submit the base class files, whoopsie, and you're going to submit all the derived class files. And that concludes today's demo. Where's my stop button? Down here somewhere. I need to stop. Where's my stop button? There it is.